Well, we've already attacked question number 2 and done A, B, C, and D in their parts. I've got 6 points. That's roughly a level 4. Let's go on to the next page and see if we can get the remaining 4 points by doing E and F. I'll do E in this video and then follow up with F later on. Well, here's the question. When a sample of sodium carbonate is placed in distilled water, this is the product that was produced in the last reaction, the student observes that the pH of the solution increases significantly. This process is represented by the balanced net ionic reaction shown below. Okay, here's our carbonate ions. They react with water, and they make the hydrogen carbonate back again, and hydroxide ions. Okay, that we understand. The student prepares a 1/10 molar sodium carbonate solution and measures the pH of the solution to be 11.65. Calculate the hydroxide ion concentration in the solution. All right, that's pretty direct. We have a pH, and we need to get the hydroxide. Now, the one thing that's not direct about it is that if you take that pH, you're going to get the hydrogen ion concentration, and you want the hydroxide. But you're a good enough AP Chemistry student to know the equation that the pH plus the pOH at room temperature is going to be 14, and coming up with the pOH that you can get the hydroxide concentration with is going to be relatively easy. I'll get my calculator up for this anyway, even though it's a pretty obvious subtraction. Nothing here is going to be useful from before, so I'll clear just to make this look a little bit better. And 14 minus the 11.65 is definitely going to give me the pOH. There's another way of solving this where you solve for the pH and use the 1 times 10 to the negative 14 relationship, and both would be certainly acceptable. Well, now that you have a pOH, you can get the hydroxide ion concentration. We're going to take the antilog, second function, log, antilog. Don't forget, though, to have a negative value here, because without that, you get a huge number, an impossible concentration, and I'll just get my answer, second function answer. Typing 2.35 would be just as good, or negative 2.35, and there's a concentration. It's nice and low. That's what you'd expect. Here we got 4,000 molar. That's a reasonable answer, and we can just indicate that. You can give it in the scientific notation or that regular notation, but don't forget to put down the molar. It's a reasonable answer. Did we answer the question? Calculate the hydroxide ion in this solution. We use the pH to get the pOH to find it. Okay, that's 1 point, I'm sure. I doubt if they give you 2 points for this. So next, write the Kb expression, the ionization constant for the base for this reaction. I certainly hope that you wouldn't have to go to the equation sheet to find out the equation for the Kb, the ionization constant for a basic solution. This should be one that you would know. Even then, you could get it away by just realizing that you've got the equation that they gave you, the equation where we're making our hydroxide ions, and just write a standard equilibrium expression for it, where we'd have products over reactants, and of course, since we have a liquid, we know that's not going to be included because liquid concentrations don't change significantly. So this would be the hydrogen carbonate times hydroxide over just the carbonate, and that would be a real quick 1 point. The only way I think you could go wrong with this, aside from putting the water in, but you wouldn't, please tell me you wouldn't, because it's a liquid and you know about KBs, is if you would have used parentheses. This is dependent upon molar concentrations, not gas pressures. If you use parentheses, they'd have to mark this wrong. Double check to make sure that you have the correct charges, the negative here and the negative and the 2 negative. I've heard graders say that unfortunately students sometimes forget to put the charges on, and if you just miss a single charge, like putting a -1 instead of a -2, they have to mark it wrong. So a quick double check, and you'll have yourself a 1 point. And again, be very careful, double check these easy points. You don't want to miss something because of an oversight. Well, on to 3. We're ready for the third point on this problem. Calculate the value of the base ionization constant for the carbonate ion. Well, we've got the equation. We just have to substitute now the amounts in these values. So we've got our equation. Here it is. Because you realized that the hydroxide ion concentration was 4 times 10 to the negative 3, or 0.0045. You had that. And whatever answer you have here, though, must be shown down here. You have to be consistent. If you had 3 times 10 to the negative 3, this answer must be 3 times 10 to the negative 3. You'd have lost the point for I, but then if you somehow came up with 4.5, they say, wait a second, where did you get that new answer? In fact, they would probably double check to make sure that anyone next to you when you took the exam wasn't too close to you, because they would worry that you were copying. So be consistent. We've got that. We know the hydroxide ion. We know the equation where we've got the hydroxide ion concentration and the carbonate ion concentration being the same, 1 to 1. We didn't add anything to this. We didn't add any acid. We didn't add any base. There's no common ion. This is just simple ionization. So this is just going to be this squared. Now we go back and read to the very top. It said the student prepared a 1/10 molar. You might have to scroll up there in case you'd forgotten there's a 1/10 molar. And that's what you'd have here. Now, being exactly right on this 1/10 molar is at the start of the reaction, and some of this stuff ionizes, and when it ionizes, you're going to lose some of this 1/10. So the perfectly correct method would be to make sure you subtract this value from it. Now, it's such a small value that it's not going to make any difference. And on this exam specifically, I don't think they minded. They even gave this as their option, where the KB is approximately 1/10. But I would be cautious. On some other problems, it could make a difference. I'll pull my calculator out and we'll see how we can take this thing. In fact, actually, we've got our previous answer, and all I've got to do is square it, and squared, and I'm going to divide, and I can take the 0.1 and subtract the amount that ionizes, the 0.00447. That's being excessive, but there we have our answer, 2.08 times 10 to the negative 4. The exact answer, this is only good to 2 significant digits, really 2.1. I'll show you that if we took our 0.00447 and divided it by, square it, and divided it by the 0.1, we get our 2.0 times 10 to the negative 4. This is the difference between the two. This is why I like to put this in. It's there, and this is marginally. This is like 0.004, a little bit higher, and it would have an impact. So, piece of advice. In this case, you didn't have to worry about the initial amount being subtracted, but include it regularly, because there might be a question where it is important. Well, we've got probably our 3 points here. 1 point is earned for the correct value, and we've got the value. But don't forget, you have to show your work. You got to show some numbers up there so that they know that you didn't copy somebody else's answer for this. You don't have to show all of this, but do show a significant amount of work. Whatever you put in your calculator, you write down on the sheet, because if you get the right answer, you want to get credit for it, and you don't get credit unless you show the numbers that you use. All right, now to the last part.